3.3 zeros of polynomial functions. So we'll be finding if things are factors using the rational zeros theorem, finding zeros, conjugate zeros theorem. So this is kind of a longer section, so I'm planning on splitting it up over today and tomorrow to kind of give us a breaking point there before we kind of like finish the section, just because it is kind of long. So use the factor theorem and synthetic division to decide whether the second polynomial is a factor of the first. So I'm pretty much just going to use synthetic division because it's going to kind of lead into what we are getting ready to do. So number 10, we've got x cubed plus 6x squared minus 2x minus 7, and we've got x plus 1 is the factor. So we'll do this just like when we did synthetic division. We'll change the sign here. We'll run synthetic division. If we get a 0 at the end, then it is a factor. If we don't get a 0, then it's not a factor. So -1 is going in the box. Copy down the numbers. Remember, if there's any terms missing, then we have to put in a 0. In this case, there are not. So 1, 6, -2, -7. So we bring down the 1. Times -1 is -1. Plus 6 is 5. Times -1 is -5. Minus 2 is -7. Times -1 is 7. Minus 7 is 0. So this came out to be a 0, so that tells us that x plus 1 is a factor. Let's see, jumping down, number 18, 2x cubed plus x plus 2. And the second one is x plus 1. So -1 goes in the box. Remember, opposite sign here. 2, I'm missing the x squared term, so I need a 0. Then 1 and 2. Bring down the 2, times -1 is -2, plus 0 is -2, times -1 is +2, plus 1 is 3, times -1 is -3, plus 2 is -1. So this one has a remainder, and so x plus 1 is not a factor for this one. So basically you're showing the synthetic, and then you're just saying if it's a factor or not for those problems. All right, factor the function into linear factors given that k is a 0. So this is taking it a little bit farther than what we were doing in 3.2. So 22, I've got f of x equals 2x cubed minus 3x squared minus 5x plus 6, and k is equal to 1. So what they have done is they have told us that this is a 0. They've told us that. But one, we want to always like confirm it, but in confirming it, it's going to break it down so that we can break it into factors. Okay. Y'all could factor something that's like x squared plus 4x equal or plus 4, right? Like y'all could factor that. So what we're doing is we're trying to get it down so that we can factor something that's bigger than just a quadratic, basically. Okay, so that's what this is going to allow us to do. So we have, this is a 0, so I'm going to plug that in exactly, okay, because it's, remember, if it's k equals, we plug it in exactly. If it's x plus or minus something, we change the sign when we put it in the box. So then 2, -3, -5, and 6. So we're going to bring down the 2. Times 1 is 2, minus 3 is -1, times 1 is -1, minus 5 is -6, times 1 is -6, plus 6 is 0. So we have confirmed officially that this is a 0, okay? So we know that x is equal to 1 is a 0. To make it a factor, I need to move the 1 over. So x minus 1 equals 0. So this is the factor. So what I a lot of times will do, because this is leading into the remainder of the section, is I'll kind of like circle where the factors are as I work my way down. Now, when we were done with the first set of synthetic the other day, or like where we were stopping, we said if this was an x cubed term to start, this was an x squared term afterwards. So this is 2x squared minus x minus 6. Now I need to factor this more. So now this is a quadratic, nice and easy. I know how to factor that. So using the arch method, I need factors of -12 that when added together give me a -1. What factors of 12 would do that? 3 and -4. So 2x squared minus 4x plus 3x minus 6. Factor by grouping. What can I take out of this first one? 2x, and that leaves me with x minus 2. What can I take out of the second one? That leaves me with x minus 2. These match, so I have 2x plus 3 times x minus 2. And these are 2 more factors. Okay, so I have 1 factor here, 2 factor, 3 factors. So x minus 1 times 2x plus 3 times x minus 2, and this would be in factored form. Okay, so how they want it broken down. Makes sense? So it's essentially just taking it a step farther than what we were doing the other day. When we were doing like the linear factorization thing, this is pretty much just taking it a little bit farther. Let's see. I have some big numbers. (26) f of x equals 8x cubed plus 50x squared plus 47x minus 15, and they tell us that k equals -5. So, -5 in the box. I don't have any missing terms this time. So I've got 8, 50, 47, and -15. Bring down the 8. 8 times -5 is -40. Plus 50 is 10. Times -5 is -50. Plus 47 is -3. Times -5 is +15, minus 15 is 0. So this factor would be x plus 5. Okay? Are we tracking on that? Okay. So then I'm left with 8x squared plus 10x minus 3. So I've got factors of negative 24 that add up to give me a positive 10. What would those be?
Negative 12 and 2. No, wait. 12 and negative 2.
Yep, 12 and negative 2. I knew you'd figure it out. All right, so we've got, well, it doesn't matter. 8x squared plus 12x minus 2x minus 3. What am I taking out of the first grouping? 4x. And that leaves me with 2x plus 3. What am I taking out of this one? Yep, a negative. So 2x plus 3. So I've got 4x minus 1 times 2x plus 3. And then if you want, you could just bring this factor on down and not have to rewrite the whole thing and multiply it by x plus 5. And there is your factored form. So I should write f of x equals on that. All right, I am going to maybe not do those ones. No, we're gonna look at that concept in a later problem. Never mind. Okay. All right, jumping down, we have a polynomial function and it wants us to list all possible rational zeros, find all rational zeros, and factor into its linear factors. Okay, so okay. Start with number 40. We've got f of x equals x cubed plus 5x squared plus 2x minus 8. All right, so the way the finding all possible rational zeros works, okay, because right now they haven't given you anything that they've even remotely told you is a zero, okay, and you probably don't know how to factor this without having some more information. So, get this focus back in. What we do is I was trying to see if it was written this way in your notes or not. Some books write it this way and some don't, so. All right, so the way it was written in your notes, it said if P over Q is a rational number and if P over Q is a 0 of f, a polynomial function with integer coefficients, then P is a factor of the constant term, so that would be this number right here. And Q is a factor of the leading coefficient, so that would be the number in front here, which is really nice when it's 1. If it's a number other than 1, it gets to be a little bit more complicated. But what we do is we're going to factor or find all the different factors, and then we're going to check them. So what we do is we say it's the factors of the constant term over the factors of the leading coefficient. So this is plus or minus 8 over plus or minus 1. So it doesn't matter what sign's out here. We always put plus or minus. Same thing for here. And then I need different factors of 8. Okay? So I know okay, 1 times 8 and 2 times 4, there aren't any more. So what we write is plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. And then we would do the same thing on the bottom. Since it's just 1, it's just plus or minus 1. Now, I'm going to write it out with this one. Normally, if it's over 1, we will not write this step. we would have just not written the over plus or minus 1. But I just want you to see it on this like easier one before we move into some harder ones and like later problems. So we would write plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. If there's a number on the bottom other than 1, then we obviously are going to end up with some fractions in there also. If there's ever a time where something is repeated, so let's say that like 2 is a factor on the bottom, and I would end up with, okay, 4 over 2, well, that reduces to 2, and I've already written 2, so I don't write it again. Okay, and that'll be easier to see. I don't know, this section may have all the leading coefficients. Nope, they're not all 1. Okay, beautiful. So we'll like write them all out. But this one has 8 possible zeros, okay? Because each of these numbers could be plus or minus, and so there's 8 possible zeros here. So that's part A, technically, that it has asked us for. Part B says find all rational zeros. So what we do, you need your calculator. So what you're going to do is you're going to hit y equals, clear whatever's in there, and we are going to type in this function right here. So this x cubed plus 5x squared plus 2x minus 8. And then you're going to hit zoom in 6. Now, we're looking for where it crosses the graph here. So where does it look like there are zeros?
Where it crosses the x-axis and the y-axis.
So where it crosses the x, but like, sorry, I should be more specific. What numbers does it look like that's happening at? You can look at your graph too, it should be the same.
I got the x cubed right. Oh.
The whole function.
Okay. 1.
Okay, 1 is one of them. Or, well, we're going to check 1. What else?
-2.
-2 and -4. Okay, so we're going to pick one of them. Which one do you want to choose? I don't care. 1. All right, beautiful. So now we are going to plug 1 in as synthetic division. So 1, 5, 2, -8. So we bring down the 1, times 1 is 1, plus 5 is 6, plus 1, or not, whoa, hold on. Times 1 is 6, plus 2 is 8, times 1 is 8, 8 minus 8 is 0. So we have confirmed that x minus 1 would be a factor because 1 is a 0. So we've confirmed that that's a 0. Now, at this point, I'm left with x squared plus 6x plus 8. You can factor that, right? What would that factor into if you did that?
4 and 2.
So x plus 4 and x plus 2. And what do we know? -4 and -2 would be zeros. Multiply it by -1, or the x minus 1, and that would be it factored out for you. Okay? Now, if it wasn't something that we could factor, we could keep the process going. Okay, we could have just run synthetic again on this set of numbers that was down here. So let's see. 44. F of x equals 15x cubed plus 61x squared plus 2x minus 8. So I would have plus or minus 8 over plus or minus 15. 8 we did in the last one, so that's 1. And all these are plus or minus. I'm not saying it every time. So 1, 2, 4, and 8. What about 15? Yep, 1, 3, 5, and 15. All right, so now type this in your graph and see. Oh, wait, sorry, I'm missing a step. We need to write out all the zeros first. Then we'll do that. All right, so all these numbers get written over 1. Okay, so we're going to have, and all these are going to be plus or minus. I'm just not going to say it every time. So we've got 1, 2, 4, and 8. So that's all the numbers written over 1. Okay. Next, I have all the numbers written over 3. So this would be 1/3, 2/3, 4/3, and 8/3. Then write the numbers over 5. So 1/5, 2/5, 4/5, 8/5. Now, this one's one where, like, nothing reduces. Normally, you don't end up with this many. This one's, like, kind of obnoxious. All right, and then everything over 15. So this would be 1/15, 2/15, 4/15, and 8/15. All right, so this one had a lot of options. So now type this in and look and see which ones look like they could be zeros. So type that graph, or like type that function in and like to the graph and see which ones could possibly be zeros. Instead of 4. Any others? So I would say if you're saying it's a half, it's probably somewhere between 4/5 and 2/3. Just a guess. Because it has to be one of the numbers that's listed that we wrote down.
I don't know, I'm really assuming that I can't figure out Zoom.
All right, so if we want to zoom in on this area, then you hit, let's see, zoom, and then arrow, or not arrow, first option is box. So what we do is we would arrow over to the left a little bit and hit enter, arrow up, and then arrow to the right, and you're going to notice it's making a little box here. So I'm going to zoom it in. So I would say this one is probably either a positive 1/3 or the like 2/5 option. This one over here is probably negative. What are my options? Could be negative 2/5. It's kind of hard to know. So we're going to go with the one that we confidently know first, which is 4, but I think it's negative 4 based on what the graph looks like because it's intersecting over here. So this is negative 4. So we're going to run that one first because that should in theory be the easiest one. So negative 4, then I've got 15, 61, whoops, I don't know why I'm putting commas there, 2, and 8, negative 8. 15, 61. Yeah, okay. So then, bring down 15, times negative 4 is negative 60, plus 1 is 1, times negative 4 is negative 4, plus 2 is negative 2, times negative 4 is a positive 8, minus 8 is 0. So I'm left with currently 15x, x squared minus x minus 2. Now at this point, we could just factor this, which is going to be the easiest since we're not sure about those. So what would this factor into? So I need factors of negative 30 that equal negative 1 when added together. Negative 6 and 5. So I'm going to do 15x squared plus 5x minus 6x minus 2. Take out a 5x. I'm left with 3x plus 1. Take out a negative 2. I'm left with 3x plus 1. So I would have 5x minus 2 times 3x plus 1 times, up here, this one would be x plus 4. And that would be it factored out for you. All right, I'm going to go ahead and stop there because that's kind of like the midpoint of the section. I'm going to do probably one more of these ones tomorrow. I'm only going to give you one that has a 1 in front for right now, and we'll do one more of these ones tomorrow to kind of start and then finish the last few things in this section. It's really only one more like kind of big topic in this section, but I would rather be able to break it up and do the rest of it tomorrow. So to this point, problems, we've got, let's see, 11, 15, 21, 25, and let's do 39 and 41. And again, those ones just have a 1 in front.